Have you used any AI agent before? Shout yes or no. No? OK. So for people who said yes, can you tell me an example of agents? And don't do cheating. If you're part of talk, don't talk about that. You people identify yourself, don't talk about it. So people who are not part of that talk, what agent have you been using? Any example? It's just shout.
N8N.
N8N, yeah, that's an agentic framework. But any agent did you use, like in your daily life? No? You have used. Others? Yes? For writing a unit test. What is that? What did you use for writing a unit test? Copilot. So Copilot comes with the agent mode, right? So that's agent. Correct? So how many of you use Copilot? Almost everyone, right? Copilot, Cursor, Windsurf, that's all coding assistants. ChatGPT provides agents now, right? Or rather, like the simplest form of agent is essentially you go to ChatGPT and you ask, what's the news today? That's the simplest form of thing. LLM on its own do not have understanding about this, like because it was, I don't know, trained some time ago. So it kind of does a web search, gets back information for you, and presents you with the news for today, right? That's the simplest form of agent, right? Or a pretty cool form of agent could be like, I don't know, you have that. Have you seen that? Now you can actually go to ChatGPT and enable the agent mode and ask it to book tickets for you, let's say for a movie. And it can actually build up a small instance of computer. Have you actually seen that? Have you tried agents from ChatGPT? No? Oh, you should try it. It's fun. Or there is another example from Manus AI, which is also quite cool. Maybe you should try it out. So our goal for today is to kind of equip you with at least understanding about the basic forms of agents. So at the end of the 2 hour, you will not be calling yourself expert in agents. Let me clarify that. You will be calling yourself, OK, you will just be knowing what is agents and actually go happily after building a simple agent which you can actually use to book your own travel. Right? So I think we'll give you a repo where you can actually understand what's going on behind the scenes, and I can actually show you like what we should actually be able to understand towards the end of the workshop. Fair enough? Let me see if this works. It doesn't. This doesn't work. So I'll quickly show you a quick demo while we settle this. So anybody is going to have a plan to go to a vacation in a recent future, in coming days? Yeah, where do you want to go? Huh? Kulkarni you want to go. OK. When do you want to go? Let's plan a trip for you. So what we have right now is actually a simple agent. I call it travel agent. I'm not sure if it's visible for you folks. It's connected? Yeah. OK.
Oh, you not use for this. You can only use for PPT.
No, that's fine. I'll go there and do it. That's OK. OK, so what I'm going to show you right now one repo that actually you will be able to understand what's going on behind the scene. You may not be able to build it at the end of 2 hours, and that is fine. But even if you're able to understand what's going on behind what I'm going to show you, that's a win. All right? That's a good expectation for you folks? Right? OK. So I'm going to just start an application, and I'll say hi. And it says, hello, I'm glad to hear from you. It's an assistant that can actually help me with hotel bookings, flights, and even suggest an itinerary. So may I ask you, you want to go to Kulkarni. When do you want to go to Kulkarni? September, OK. I want to go to Kulkarni. From Bangalore? In September. Huh? September 1st, OK. So I just asked this question that I want to actually go to Gokarna. What did it say? OK, this sounds fantastic trip. Would you like help with the booking flights or hotel? What do you want? You want to book? Let's book a flight, I guess, for you, right? Let's book a flight. So what it did is, there's actually a multi-agent system going behind the scene. We'll not talk about multi-agent system, but this is just to give you a flavor. So there was a supervisor agent that was actually just handed over the question. Since I asked for flight, it handed over to flight advisor. And it says, OK, could you please provide me the date for your return flight? Like, we didn't provide the date for return flight. So I say, I will be there for 4 days. Did it ask me a number of passengers I didn't give? So essentially what happened is it's a kind of a multi-agent system where it has multiple capabilities and different agent is able to do different things. So what we want is how this is actually happening behind the scene is what we'll be able to do it at the end of it. And Murphy's Law.
It's not connected to internet.
Oh, maybe it is not connected to internet. No, it is connected to internet.
Is it very slow? That is the problem.
That's OK. That's OK. It doesn't matter. You don't need to understand like what's going on. So essentially what it did is, what we are going to do behind the scene is, we'll make sure that you are actually going to call an API. That API is, let's say, Google's API for flights. And that API will bring back flights. Right? That's all what it'll do behind the scene. So that's how we are actually going to do is something you will see at the end of the workshop. Right? So let's understand what is agents first. And OK. So the repo that the code I was kind of showing to you, you can actually scan the QR code. Maybe take a picture if you want for now. And that's a repo where you can actually find the entire code for what we just showed. All right. OK. So the type of agent that we are going to start with is called React agent. It's the simplest form of agent. And whenever you're starting with any agentic application, most likely you're starting with this type of agent. Right? And for your information, actually, React agent is something. So it was actually a paper that was published, I don't know, right after ChatGPT came in. So it was kind of a if you Google it, it's kind of a React paper, not agent. It was not called agent at that point in time, but the technique was used to build the very first agent. And we'll be able to build this at the end of the day. And the way this works is, so it works in 3 steps. It's thoughts, actions, and observations. It's like you can imagine that this is something similar to what a human would do, right? So imagine that you are actually, can you make this work, please? So the thing is, you want to make a Turdal. Okay, you want to build an agent. Everyone, please, can you please give eyes to me? Maybe you can just close the lids for a few minutes. Just focus on this. We have a small theory, and then we'll actually get into practice. So even if your pip install is not working or something is not working, it's fine. So people on the front row, can you please close the lids? Excuse me. Yeah, just close the lids for time being. So how would you go about building, making a Turdal, making a dal as a human? What I would do is, if I want to make a Turdal, the first thing I'll do is, OK, I should first check if I have a Turdal. Right? That's what we'll do. Then the immediate next step would be, OK, if I want to check if I have a Turdal, what would be your action? what will be your action? Go and check if you have a tur dal, right? Go to kitchen, pantry, and open the dal container and see if you have tur dal, right? Now you went there to kitchen, opened the pantry, and now you have a box in your hand, and what you say is, oh, it's empty, right? What do you do next? Order from Blinkit, yes. That's a good thought. That's another thought, right? So after you completed a thought, action, observation, and based on observation, the next thought was order from Blinkit. Or check if you have anything else, right? Maybe masoor dal, right? And then if that's your thought, the action would be look at the other container, and then you say, there is a packet available, and then you changed, right? Or if you want to order from Blinkit, then the action would be to open the phone and actually place an order, and the observation is that yes, the order is successful, and then maybe the thought is, okay, I need to wait for 10 more minutes, right? So that's actually what you would do, right? That's what a human would do. Right. That's actually what agent does. This is exactly what agent does. So the React agent, as the name suggests, the RE is for reason, and ACT is for act. How many of you know about reasoning models? Reasoning models, they become a thing now, right? O3, O4 mini, used it? How many of you use O3? O3. Even, how many of you use Claude Sonnet, right? You use all the model, and it also comes with thinking, right? Or DeepSeek R1, right? The thinking model. Right? That's actually a reasoning model, and it can actually reason about things, right? And then there's also, in prompt engineering, there's also a thing around, like, there's actually a specific style of prompting technique in prompt engineering to actually force model to do reasoning. What is the name of that? Chain of thought, yes. That's actually, you force a model to think, right? And then spit out tokens, which are actually thinking tokens, and then you actually get a better output. That was the observation. That was actually coming from the React paper. And then they found out that that's a really cool technique. Let's actually bake in the chain of thought into the model, and that's how reasoning models came in picture, right? And now what we're doing here is the same thing, but you're actually forcing the model to actually go through 3 different distinct processes, like thought, action, and observation. And we'll show you practically how it actually works, okay? So the first thing is, if user asks, let's say, how many moons does Mars have? Now, if I ask this question to LLM, and if I have to force the LLM to think in the thought, action, and observation space, how it works. So you first ask the question, user, how many moons does Mars have? Thought would be, I need to look up this information, right? Maybe assume that LLM doesn't know it, right? Maybe obviously LLM knows it, but assume it LLM doesn't know it. So that's the next thought that LLM will spit out. That's actually, you will force it to do it. Then the action would be, okay, if I don't know it, I need to look out the information. What I'll do, I'll search web. And then I'll search web with Mars moons. And I'll get some results, right? So that's the action that happens. And the observation is that Mars has 2 moons, Phobos and Deimos. And then you go to the next immediate thought is, okay, the user asked for a number, I have found it, and I can now answer. And basically you have a final answer, right? These are the steps the agent takes, or we force agent to take to come up with an answer. Now tell me, if I come and ask a question that, what is the news today? Like, what is the latest news for today? What will happen? What would be thought? I need to first look up the information. The action would be search web for latest news. Observation is, you actually found like a bunch of pages, and based on that pages, the thought is, okay, I have all the information required, or maybe you can put the news you fetched from the internet, and your final answer is the article or whatever news pointers you would put in the answer. Make sense? You folks are with me? Right? All right. So what is an agent? Right? So let's understand what is an agent. So in this case, I actually give you the most simplest form of an agent. So in this case, user is asking for something. But maybe agent is not just related to that. So for example, imagine a world where we have, maybe 10 years from now, actually we have a lot of good motion sensors. And everywhere there is AI. I'm pretty sure AI penetration will be like super high, right? So imagine that I'm standing here, there are cameras here, and camera is tracking my motions. So maybe if I while talking to you, I come here and maybe just fell off the stage or something gets hurt, I get hurt. Maybe there is, the camera itself has a detection about, okay, there is something wrong. I need to alert somebody. So it'll quickly alert someone, right? Or maybe if you're actually having cameras on the road and the accident happens, you want to automatically alert a particular system where maybe it automatically alerts police and a nearby hospital to send ambulance. That would be really cool, right? So I think that that itself is kind of a part of this agent. We will not talk about it today, but it is part of agent. And so if you want to think about like what is an agent, you can think about agent. There's no formal definition of agent, even when we're talking right now. So nobody has actually formulated agent. And then some people debate that agent could be something really big. And some people say that a simple agent is like what we also talked about is also agent, right? We'll stick to the second definition for now. We don't want to do something big for now, okay? So the agent is, it perceives things, right? So it can basically understand. For example, a perception could be that I opened a dal container and I saw that there is nothing. Right? That's a perception. I understood that there is actually something missing. And now, based on what I saw, I want to take a decision. What happened? Oh, no. I want to take a decision, right? What was the decision there? To open the dal container, right? I opened the dal container. That was the decision. And then the action was actually went physically, opened it. Right? Or in the case of latest news, I actually did the web search. That's the action I take. And the action is in the outer world, okay? It's not part of LLM. So the action is always in the outer world. I'll show how it is done. It is done through something called as, how do you take action using LLM? Yes, you do API call, but how do you do it? Tools, yes. Function calling, it is done through tool calling or function calling. We'll talk about it just in a bit. But that's an action. And then it learns along the way, right? So for example, in the morning, I couldn't find tur dal, and I didn't order from Blinkit. Then in the evening, I should not have the thought again, right? I might have that thought again, but I learned that, oh, we don't have it. So I need to order either. So the next thought could be I order it, or if I want to still go with the masoor dal in the evening, that's fine. Right? So it needs to have also some sort of a memory. So that's actually the learning aspect of it. With me? So that's an agent. So we're talking about mota, these four things when you're talking about agents. All right? Okay, cool. So let's talk about the action part. Let's zoom in a little bit onto the act part, okay? And that act part, as we just established, is called done through function calling. Okay? So another simple example of what a function calling is. So let's say if I say that, what's the weather in Pune? By the way, I come from Pune. I came for the conference in Bangalore. So weather in Pune is as good as Bangalore. So I don't know, there is some sort of a misconception, so I keep saying that. So the weather, so somebody asks, what's weather in Pune? And you ask it to LLM. Will LLM be able to answer that question? No? How many say no? Can somebody say yes? Why it can't give answer? Why it doesn't know about current weather? Yeah. How many of you follow that? So when LLMs are actually created, right, they were actually trained until a particular point in time, right? So if you go to ChatGPT, today it has access to all sorts of tools. It's kind of an agent in a way. But if you do this, go back 2 years and ask this type of question, it will not have access to any tools. So it will basically hallucinate, and it will say that, or if it is in a good mood, it will say that my knowledge cutoff date was September 2023, so I don't know what's going on post that, right? Remember that? Have you seen that message from ChatGPT? If it is kind enough to do that, it will do it. So if it is not, I asked ChatGPT and said that there is actually a very famous author called as Sarang Kulkarni. That's me, by the way. And can you name 10 books written by him? And it did. It did quite a lot. It gave me some nice books. And I was actually expert in different areas from that book. But it is not true. That is actually hallucination. So if it is in good mood, it will say, I don't have access to specific weather details in Pune. That's good. If you want to actually answer this question, you need something called as function calling. So if I just ask the same question for LLM with function calling capabilities, what I'll do is, now I have a LLM, but what I've done is, in my application, I have also given that LLM access to a particular tool. Let's say it's a weather tool. What will happen is, LLM will say that I do not know the answer to this question, but I have actually access to a tool, and I'm confident that that tool will be able to answer this question. So what I'll do, I will actually tell human to call that tool. So it will say that, it will not answer, it will say that, it will spit out this JSON format and say that you should call getCurrentWeather method with the argument location as Pune, and the unit should be in degrees Celsius. Right? That's what it will say. And what you and me as a programmer need to do is listen to LLM. So listen to that. It is asking me to call a method, so I'd go and actually call a method, right, with the arguments provided by LLM. And once you call the method, behind the scene, maybe you have a weather API, you're making a call to weather API. And that weather API will go and give me back information. So that's actually real-time information you're talking about. This is outside the space of LLM. Fair enough? And this gives me back answer that 25 degrees Celsius. Now I take that 25 degrees Celsius answer and give it back to LLM. And now what happens is LLM has the context of original question. It knows what I have asked, and it will give me back answer. That this is actually it's 25 degrees Celsius in Pune, right? Cool. So that is function calling. How many of you have heard about a really hyped out term around this? There is something really cool happening around function calling. MCP, right? I think there's a lot of hype around MCP. And MCP, why there is so much hype? Because LLM is actually just disconnected from the world. And MCP bridges that gap to actually connect this LLM with the entire world. So the bigger problem here is, how do you actually know that this getCurrentWeather method exists? So if you want to actually know that, you need to actually type that method out in your system and then make that call. Whereas what MCP is doing is, it's actually making all those tools, I'm going to call them tools here onwards, available in a server where LLM just knows where to go and ask. Like LLM can just understand that these are the tools available, and you can easily call those tools through MCP, right? So we'll not talk a lot about MCP today, but MCP comes here. If you actually heard about it, it comes here. So now you can use the same thing to get latest news, right? You can use the same thing for data analysis. You could use the same thing for, I don't know, finding the best phone in the budget, right? So you could do this, right? So maybe if you go back, start with these simpler applications. Like go and build this. I think we'll also show you hands-on right now on how to do it. So with this, we'll kind of jump into first notebook. And how many of you are actually not able to install stuff? Can you please raise hand? If you're stuck, maybe I can come around and maybe help you out. Anybody here who is not able to install things yet and is still struggling with the installation? OK, 1 or 2 people. I think we have. Maybe volunteers could just help them out. Awesome. Then you can please scan the QR code. OK, this QR code contains OpenAI API key, which costs a lot of money. We are giving you here that for free, only for the workshop. Don't WhatsApp these keys to anybody. Promise?
It's a valid. Yes.
It's only valid for until this workshop ends. Turn off your WhatsApp. You folks are able to scan this and then copy it, into put it into your .env. You want that mic? Oh, no. No. Can you do Jupyter Notebook with this? You could just run all. Just run all. Yeah. There is a possibility of rate limits with keys because we only have one key. So maybe do we have one more key? We'll create.
Mic check. Can folks hear me? Okay, cool. So thank you, Sarang, for telling us the basics of React Agent. Again, I am the kind of guy who understands a lot more by looking at code, and that too, the basics of things. Maybe I'm old enough that I cannot jump from the A to the C's directly. I need to go A, B, C, D, step by step to understand how things work. So the first notebook is about implementing this React Agent in pure Python. No LangGraph, no frameworks have been introduced yet. So we'll go through this step by step. We then have 10 minutes for you to try it on your own. So again, maybe right now I will kind of walk you through these steps, and then you can do the hands-on yourself.
Yeah.
Yeah, please eyes to the demonstration for a minute. Maybe I think you can then just try it on your own a little later. We'll give you time for that. Yeah. So please close the lids of your laptop. It's usually easier. We are humans, and I know that if I'm stuck into something, I don't want to actually look at anything else. So for time being, just close the lids, and then maybe take a look at here, and then maybe you can just continue.
So I'm just restarting this Jupyter Notebook from scratch. This first command is really loading up your environment variables. The OpenAI key that you would have scanned, we would need to keep this in the .env file. So we'll do that. Zoom. Zoom कैसे? How do you zoom it?
Command press.
Yeah, so the first block really is just setting up, the libraries that you need and loading up your file. Here we are creating an OpenAI, client. This is again an OpenAI Python library that you can look at, and you can understand, the different mechanisms that come out of it. And just to ensure that your setups are done correctly, we initially call OpenAI with a hello world, input or a hello world prompt. And in the chat completions, it comes out with the answer. So if any of your setups are not working, if you're not connected to internet, if you run out of the key, hopefully not, by the time at least this session completes, you should see something like this, okay? So this is where the meat of this program starts. So we are creating an agent class where if you look at it, really it is keeping context or memory, within itself. So it's an array that is initialized, with an empty array. And any time that we are interacting with the LLM, we are going to essentially store the request and the response in this to serve as a contiguous block of memory. There is a call function which essentially calls, the execute function, which is how we interact with OpenAI. So the same call that we saw above has been wrapped up in a function. Again, model, it's all well documented. So you select the model, you have selected GPT-4o out here. You select a temperature range where temperature of 0 means very less or no randomness. Whereas if you give a higher temperature, the model starts hallucinating a little bit, but you might need it in certain creative spaces at that point. And then it returns whatever the model has spit out at that point. Okay? So really the meat of the TAO framework that Sarang was talking about, the thought, action, observation, is in the prompt by which we are initializing this agent. So whatever we spoke so far, we are initializing it via this prompt behavior, which is going to go to the LLM to say that, hey, you're a helpful travel assistant. So again, there's a lot of prompt engineering theory that we will not get into today. But there are prompting best practices now because, like as Andre Karpathy said, now we are in the era of software 3.0 where we are essentially activating different weights via the prompts. So that's a very interesting area that even you write it a certain way, you get better results versus if you don't write it in a certain way, you get slightly worse off results. So what are some of the best practices that we have followed here? We have given it a persona that you're a travel agent. We have given it a precise direction to say that you're in a thought, action, pause, observation mode. And I'll explain why we did pauses just to show you, the steps as we go through the loop. And then we will eventually have another one that goes through the loop itself. The other part that Sarang was talking about, that how does the LLM know what tools does it have access to? And again, there's no magic here. There is literally information that we are giving about every tool that it has access to, in terms of what is the name of the tool, what are roughly the inputs that it takes, what are the outputs that it can give, so that the LLM can actually decide, hey, I have such and such tool, and in my thought, I can suggest the action that it can take. Again, a lot of prompt engineering best practices will talk about few-shot prompt, dynamic few-shot prompts, where it's always better to give the LLM a representation of how this interaction will go. And this is what we have laid it out here, that, hey, for example, if the user asks, such and such question, you respond in such and such way, then the user will do this, user will do that, and what is the final answer, that is expected. So there is a lot that goes into it. Some of that is not very, very obvious also in many ways. So as we all learn this space, this new and exciting, Gen AI space, we'll understand either implicitly what works or what doesn't work, or there is an excellent website called as promptingguide.ai that talks through a lot of this theory. So I highly, recommend folks go through it. So then the tools that we talked about, we have to obviously have implementations of those tools as well. So for the purposes of this demo, we have basically stubbed out implementations, but to calculate something like if the cost of a ticket for one person is 5,000 rupees, what is it for two? Eval is a very friendly Python function that can take string inputs and kind of give you mathematical outputs. Of course, it's not recommended for production at all because it can get into a lot of other crazy things. For flight route info, again, it's all these are dictionaries, essentially maps, key values that you see, that if they got called with a certain key, then it will return a certain value. Otherwise, it will return with a value saying, hey, I'm not aware of this information, or it's not available. The same goes for weather as well. If you call it with a city that it recognizes, and Pune is not in here, so we will call it with Pune. Let's see what happens. It will come back and say, hey, I can't give you that information. This array would be needed later on for our automation loop. So we are just kind of keeping again a key value link to say that if the LLM suggested an action called as calculate, then you can call this calculate method with that. So this is all kind of the pre-setup. And now we will go ahead and we'll create the bot or agent. And the first thing that we ask it is, what is the weather like in Paris? So if you join all the dots, it's going to put it in the array, the request, it has initialized with this whole prompt. It will have a thought, it will suggest an action, and it will pause for us to do that action if everything goes well. So let's see what happens here. Okay, perfect. It said, I need to get the current weather information for Paris. And given the information that you gave me, that I have certain tools that are available for me to use, the most relevant tool I believe I can call is get weather for Paris. Okay? So we take this action and we execute it. So there is a key value pair that you saw, it returns 18 degrees centigrade, nothing, no magic there again. And this we feed it back as an observation to say that this was the observation that came. Now, what do you want to do about it? So here, because that was essentially the answer that we were asking for, the LLM decided that, hey, I think I've mostly found it, it looks good, so let me return back with an answer at that point. Okay, and just to show that all these messages are getting stored in the memory or in the context, if you will, because it's getting fed back again and again. Like if you look at the code, we are feeding it everything back again. So this goes to show that everything is getting tracked about. Now let's make it do two things. This was very simple, right? It just had to call one tool and it was done. So we reinitialize the agent. And here we are asking both a flight kind of data or details as well as weather kind of details. So let's see if it decided to continue that loop for 2 times before it felt it had an answer. So let's start with this. So the first tool that it felt it needs to call is the get flight info, because our prompt is I am planning a trip from New York to London. What are the flight costs and duration? What's the weather like? So it said, okay, let me get the flight info. Okay, here something did not go as expected. Let's see if I run it again. Does it find it? So here it made an assumption and went ahead. But for the weather, at least it got the right information. And when we feed that in, I may have to, let's see. I'll let it run through because it's obviously now gone on a different tangent. So that also goes to show that things don't work out perfectly in some cases. And here it is obviously not come with the answer. We would have had to add more steps in our notebook. But really, what we are doing out here is we were running the tools, for itself. So if we create a loop of sorts, which is this function right here, in which we absolutely have to have a exit criteria, right? Because we don't know how many loops or how many iterations are actually needed to answer this question. But can we let it run forever? Obviously not, infinite loops, lots of problems. So this loop has 2 clear exit conditions. One is we have given it 5 turns. And if you still feel you did not get an answer till 5 turns, then you in any case have to exit. Or in a production system, we will detect that and we will say, maybe cut short your question or do something different. But on the other side, for every answer that it is returning, we wrote a small regular expression to say that does the answer have an action that is recommended? And if the action is in our known set of actions, because again, see, we can give it all the tools in the world, but if it's not a tool that we recognize, we still can't do much about it. So that would be another way in which it would exit out if it returned an action that we don't understand. Or if it did not return an action, because if you see above, how is it answering, when the answer comes out somewhere right here, it returns as answer colon, okay, which means it has reached the end of its evaluation. So in that case as well, you can exit the loop. Okay, so that's how it is written. Otherwise, it's exactly the same thing that we have been doing. Take the prompt, take the question, feed it, get the result, feed it back again, so on and so forth. Okay, we will give you time to execute this on your own. So this will take a little bit of a time to understand, but no, nothing fancy in here. So now that this query is created, and I start by asking a question: what's the weather like in Paris? you see the same behavior that we went above step by step being executed in this loop now. And because it hit the answer, the loop was executed. We should probably put a loop number also in there, just, or you can change the code and try it as well to prove it to yourself what's happening. And it exited the loop, and it gave the answer that we were expecting. When we ask it a more complicated question, which has 2 or 3 actions that need to happen, this happens a little quickly, again, difficult to follow, but in the end, it reached the answer that we were expecting, that the flight from New York to London typically takes blah, blah, blah. The weather in London is so much. And for 2 people, remember we asked it for 2 people because we wanted to use all the tools that we had set up. We had set up an eval tool as well. It went ahead and called that eval tool and came out with the right answer as well. So that's where I think really it starts getting powerful, right? If you look at it, that it's all explainable now in some ways. Of course, still there is a lot of secret sauce and special behavior in the LLM that some of us understand. I still don't understand many things in that space, that it actually followed the instructions that we gave. But if we start trusting that capability and start augmenting it with tools that have real world information, of course we gave you stub tools, but not too difficult now to connect it to Make My Trip API or a weather API or things like that. That's when we all have something powerful now at our hands. Okay? Hopefully, big picture is clear. So you have the key that you can get from here, paste it in your .env file, and just follow the instructions in the README if people haven't. But otherwise, if you do Jupyter Notebook, you'll have a web-based version of this show up. Or if you have PyCharm or IntelliJ plugins, which is what I used, you can just run it step by step. So we'll give this activity about 10 minutes, start executing this on your own, and start getting a feel for it.
If you have any questions or any clarifications, you just raise your hand. Maybe we'll come to your desk and then answer. But meanwhile, just continue. Okay, we have a couple of people. And once you're done with the execution, just let us know. Just raise your hands. Maybe both the hands just raise once. We know that you're actually done. Some of the people are already done.
Thank you for the explanation. Sure. Okay. So what I wanted to know is, LangChain and the other framework have really made our lives simple, and it has abstracted the devil that you have just shown us, right?
That's part 2 of this.
Yeah.
We will abstract a lot of this away with LangGraph.
Yeah. So if we wanted to do a deep dive, what LangChain is showing is an abstract, and if you wanted to do a deep dive of what LangChain is as of today, for all the implementations, so what we have shown is a RAG implementation. Now we have agentic AI and then multi-agent AI. So is there a way, we can get the deep dive analysis of what RAG is doing in general?
Yeah. So again, we have to get, so a lot of material is available on more and more sophisticated techniques or what's really happening behind the scenes. Here, our view was to start very basic, see it work in Python, and then we'll convert this to LangGraph. And as you rightly said, that the loop goes away, a lot of state management comes in, a lot of human in the loop support comes in, a lot of multi-agent support comes in. So there are excellent tutorials on langgraph.com itself that if you follow, you will kind of get some of these details as well.
Time and all that. Three. It's 6. Back to the memory. Yeah.
As a chat history.
Stubbed for now, so that like you will kind of replace that stub with maybe an API call. But that is actually, you can do it on your own. That is like nothing to do with LLM. For now, we want to just focus on this bit. So that's why we just stubbed it. Yeah. It's yeah. Yeah. It is just stubbed for now, so you can actually just get the answers accordingly. Right? It's mocked for now. It's a mock data. I think even if you're done with whatever step you are in, it's totally fine. You can go back. You have the code with you. You can go back, go home, and then run everything. We need to, in the interest of time, rush. Go to the second topic that we want to cover, where we actually show you how this is done using a framework called LangGraph. Maybe that is more exciting and more interesting for you folks. All right? How many of you are ready? If you're ready, just close the lid of your laptop. Just close the lid of your laptop. Get the mic. Yeah. OK. So what we built so far was pure Python. There was no framework used, nothing, right? This was just to give you, everybody, maybe you can just stop whatever you're doing right now. Maybe just everyone. Sorry. Ready? Maybe you can stop. Priya, I think later. Let's do later. So if you're stuck, it's totally fine. So we'll take a look at like whatever we built right now so far was pure Python. Pure Python. We'll do something that with the framework, it kind of helps you a lot in a lot of different ways. And there are like a bunch of frameworks out there, not just LangGraph. There is like QAI, AutoGen, Swarm, which is now OpenAI Agent SDK. I don't know, AutoGen, bunch of them are there. Or NetN, somebody mentioned. I think you can also use it with low-code, no-code type of solutions. LangGraph is something that we feel has a very high control, and I think maybe I'll hand over Megha, just you can take over.
Thank you, Sarang. Okay, so as we increase the complexity of the agents, right, where we are involving more and more decisioning, what happens that the reliability of our agent it reduces, right? That is why the different types of framework came. So today we are going to talk about one of the framework, which is LangGraph, which will see that what all problems it is going to solve. Because earlier, like having a whatever decision we have got from the tools, right, we were not able to persist it. And plus, we were not able to involve the human in the loop. Right? If there is no human, then who will validate? If we don't validate, it can be, right? Agent can hallucinate. So that's why today we are going to talk about LangGraph. So what is LangGraph? So it is a framework which helps you to create a multi-agent agents, and which has a capability which can persist the data using the LLMs. Right? So the key features of that is stateful. Like here, you can persist the data. Cyclical, if you want to take, like, as Vishal and Sarang mentioned, we have a place where we have a tools, right, which takes some actions, right? Once you get the result, after that, you have to see that, okay, should I call to another tool, or it has to run into the loop like multiple times to get the answer in more refined way. Right? So it also gives you a cyclical graph. Then because human is in the loop, so that definitely we have more control in our whatever response we are getting. And we can we can create multiple agents working together. So let's talk about what are the three fundamental things from of a LangGraph. State, nodes, and edges. As he has already mentioned about that, we have like observation, action, reasoning, right? So it's everywhere it is the same. We just call it in a different way. So here you can see that state is the as you would have heard about the state machine in a graph, right? So here, based on the decision or based on the output, we see that whether I have to persist that data or should I override that data, right? So we are just persisting with the help of some data structures which are provided by LangGraph. Then nodes, which is a processing unit that has a functions. As already mentioned, that we have some functions, we create some functions which do some specific task. And the edges, which connects that, which controls the flow of whether I have to go to this tool or to that tool, right? So here, as I already mentioned that, we have like you can persist the data. We have different type of data structures which we can, the way we can store the state. Reducers, where you can control that, because if multiple agents we are working, right, and everyone is giving you different results and you are combining, then it can, the whole context can increase, right? So there also you can see, control that, how you have to merge the data which you have received from different nodes. And then all nodes, they can read and modify the state. Nodes is just a pure function. You give some input, it gives you some output. It doesn't have its own state. They are very specialized for a specific purpose. And as you know, like in our software world, right, we always follow a single responsibility principle, right? So here also, if you see that in agents also, that is the same thing we are doing. We are having a nodes which has their specific task. We don't give multiple tasks to one this. Otherwise, it's again like it hallucinates. Definitely in our code world where we code, there is no possibility of hallucination, but here it can. Then can be combined with complex workflows, and they don't maintain any state. Edges, as we said, right, it checks that how the nodes are connected for the execution. So simple edges is like where one node is connected to the other. And second is like conditional, where you decide that whether I have to go to this node or to this node. Entry point from where your execution has to be started. And the end, because we have to end somewhere, otherwise it will just run in a loop. So the example which just now, like before Vishal gave, right? So if you see, like, so this is like we tried to show that how it worked. So when a user gives an input, it goes to the node, LLM node. It just see that, observe that, okay, what is the question. It goes to checks that which tool has to be called. So okay, from here you can see that the question has been asked, that this is my question, I want to travel from New York to London. Now this LLM node is analyzing the tool requirements, which tool I have to call. So here it checks that, okay, this is my action, it is taking the action, okay, I want to get flight information, weather information, and the calculation. It returns back to the LLM to process all the outputs and gives it back to the user.